Good morning. I'll handle it without the microphone. Thank you very much. We are invited here to give today a small speech of the products which we are, let's say, representing in Poland. First, in the beginning, I would like to show a little bit how the market is, let's say, changing and why, let's say, the cooperation or this kind of events, also for us and especially for our suppliers, are getting more and more important. Because not all of our suppliers can, let's say, invent all new ideas only, let's say, from their own kitchen. And if you look on the market, what for me was interesting in the last years, I'm already 17 years now in Poland, 17 years working in CCTV. It all started with analog, and now it's changing into IP. So you can see, let's see here, the idea of the telephone. Here you have already the picture of screens. Yeah? You can see here the time interval all the time when, let's say, a new screen was being released was much bigger, and the time intervals that the new screen will be, let's say, released is getting smaller, smaller and smaller. Also you can see, let's say, the amount of products being released in a certain time interval are getting, let's say, much bigger. This all comes because we have much more electronics, much more devices on the market, which is, let's say, giving us this possibility. So for any multinational on the market, it's now very hard to keep, let's say, in the business. A lot of products, like for I want to take the television. The television before was only showing the picture. Now it's a device which is standing at home, which is a multimedia device. Yes. So you're not looking only television. You can use it for the internet. It's used for gaming. For example, the hall now is very important because it's standing in the central point of the house. It is being used, let's say, for the communication channel between the patient and the doctor. Yeah, so in Holland, a patient, as soon as possible, is sent back to their houses, yeah, to increase the costs for the hospital. Okay, patient is at home, but we will need some device to check that all goes well with the patient. So as we have a television at home, which is standing in central point, we have already a camera inside. It's very easy to use it to check every day. For example, a nurse in Holland is calling. The person has to go to the television, has to stand up, has to show yes, all is okay. And the doctor also can tell that you take your medicines. So more and more electronics are being used, let's say, in the house. So more and more devices will come on the market. You can see this also now, I think, with Apple. Yeah? Apple also started again. They want to start again to do something like with Apple TV. But also for a company like Apple, to have every time on their presentation something like how we call it, a wow effect, that the whole world will say, "Ooh, they made something nice that you can really use and people really like." It's starting to get more difficult for a lot of companies to invent this out of their own kitchen. So. I think at this moment you can see that a lot of companies like Google, Microsoft, all big multinationals are putting a lot of money in startups, looking around on the whole world market where they can take some new ideas which they can maybe use, let's say, in the development of a new product. Also here, let's say, Fleer develops a new product. Jacob will tell you later much more about the product by itself and about Fleer. Fleer already saw, because of using the thermal camera into automotive, so putting the camera in the car, that you can see, let's say, an animal 300, 400, 500 meters up front, let's say when you are driving. It's already increased the number of sales for thermal cameras dramatically, for us positive, because it makes the price going down. Because the price went down, the thermal cameras are already much wider used than, let's say, for 20, 30 years only in military. Thermal cameras are already a more, let's say, accepted product, even also for us in security, where, let's say, for 10 years ago, it was something like from gold or from diamonds. It was unbelievably expensive. For years now, they received something like a job to make something even smaller. They came with Lepton, as they know by themselves. Okay, they have already a very wide range of thermal products and user products, so complete products available on the market. They also understand that they will not be able to attack every vertical in the market in every specific country. So we can see now that Fleer is putting a lot of attention as a producer to, let's say, to cooperate with other companies, in other words, to deliver them only some parts, which is only the Lepton core, which, let's say, all around, like electronics, you can build by yourself. So it doesn't matter in which field you want to use it. You can see the trend, let's say. For sure, you all know that there are a lot of startup projects. This is really a trend which is growing. I was on some startups. No, for sure, when I want to start there as a startup to give my own idea, I'm for sure the oldest person there, because the average age there, I don't think it's higher than 25. So these are just students who just came from school, which are, let's say, giving here their own ideas. And, I think this is a trend which you can see on this moment. So Fleer, it's on this moment very open and very willing to cooperate with universities or with other companies. I'll give the voice now to Jacob Sobek. He will explain you more about a company like Fleer, and he will tell more about the product Lepton, which is, let's say, at this moment, I think, for you the most interesting product.
Hello, thank you very much once again for the invitation. At the beginning, I will give you a short overview about Fleer company, shortly about numbers, because all this kind of information you can find on the internet, so I will not stop very long on this point. Shortly about revenue, it's $1.5 billion in 2014, and we can divide our market where you can find Fleer products in 6 main vertical markets. First market is surveillance. For us, it's mainly border control, border security, land systems, really advanced system for tactical vision, which is used in tanks and airplanes, so really for solutions for army. Then we have detection. It's 13% of the whole thermal market from Fleer. Here we are not talking really about, not always about thermal cameras, but really about more like detectors for explosives, for biology, things for radiation. Then it's third market, which for us is Link company in Poland, is the most interesting. Then we have security market, which is for sure growing at this moment very, very quick, because like Harold Dingham has already told, price is going down so at this moment for security market, this product is also getting cheaper. That's why it's getting famous and popular at this moment. Instruments, then we are talking about radiometric camera, which is used to check the building, to check if everything is okay with your building, to get certificates, but also for electrical or mechanical systems, to check if maybe you have problems with some leaks, maybe you have problems with overheated products, then you for sure can check this with instruments. Then we have OEM and engineering. FLIR is, of course, selling products as a FLIR, but also we are inside Mobotix products. We are also inside, for example, Bosch products. So theoretically, you can have impression that you can select between different brands, but very often inside these different products, inside is always FLIR core. For us, it's a really comfortable position at that moment. And today, exactly, we will go in this topic, so thermal camera cores and components, because here price also is going down. In 1970, the cheapest thermal camera was $50,000. At this moment, to produce thermal core is around $50, so it's not so expensive anymore. And last part is maritime. Here, you're using thermal camera for boats, for ships. Also, we have instruments like radar, sonars. Also, we have camera for fishing. We have also sonar for fishing, so also something for your hobby. And maritime was first the vertical market where FLIR started. FLIR started as a Gamma company in Sweden. The problem was to navigate ships, boats when with difficult environments like a fog, and their thermal camera was the solution for that problem. When we are talking about FLIR, it's impossible to tell how much cash FLIR spent in last year in R&D. This investment is really huge. Only in 2013 it's $148 million, and this is growing. Here you can see a little bit 2012 crisis, but we are going now up again. So it's getting better. I think $148 is not a small amount of cash. I don't think so that every university in Poland can spend this amount of cash. So for us, this innovation is also very, very important to be always on the top, to be always ahead, to offer you a really good product and something that can be really innovative, because for us it's also this wow effect is also important. We are spending a lot of cash, and thanks to that we have also a lot of patents. Only in 2013 1,347 patents, so it's also showing how quick it's going and how many new innovations we have as a FLIR company. That's all about FLIR. All the rest you can find. If you would like to know something else, you can find on the internet. And now we are going to thermal. Now we are going to infrared radiation. Shortly at the beginning, when we have whole spectrum of light, here we have visible light, and later what for us as a FLIR is interesting is infrared radiation. And this infrared radiation we can split in three parts. We have shortwave from 1 to 2.5 micrometer. Then we have medium wave infrared and long wave infrared. These three parts which are for us the most often used. The most important part is long wave infrared. This is the most often used technology in thermal cameras, especially because of the price. In this spectrum we can get image from the distance around from 8 km. So mainly for security market is more than enough. We are not producing camera between 5 and 7.5 micrometer because in this wavelength we have the highest atmospheric absorption. Is because of air pollution that we cannot get infrared radiation in this spectrum. That's why for us this part of spectrum is not interesting at all. We have three different spectrums, and for every spectrum we have to produce different thermal core. First of all, long wave infrared, so this most popular spectrum of infrared radiation which we are using in the security market, and all of these cores are, let's say, the cheapest core which you can find on the market, so cores which are using long wave infrared. Then we have medium infrared wavelength, and then we have cooled thermal cores. So we have a special core which is also using a mix of gas to cool down the thermal sensor which is inside the core. It's very important to cool the sensor as much as possible down. Mainly we have this core always in temperature around minus 50 degrees. So minus 50 degrees we have temperature inside the core. And the last type of sensor is shortwave infrared, and this kind of course is used for really special applications, mainly for cameras which we are using in helicopters to find the person. And picture from this kind of sensor is looking a little bit like almost black and white picture, but it's really for a specific application. For us today, the most interesting core, which is new on the market, and I would like to give a little bit more information today about this tiny core. We are calling this lepton core. Is the name of that core. It's really small core. The question is why FLIR started with this kind of cores. At the beginning was a request from the market. This request came from the Army, from the US Army. The request was, we want to have a small camera which we can hide in the glasses. We would like to have a picture a little bit like in Google Glass, so we would like to have a picture in front of our eye. And the last camera cannot be, the price of the camera cannot be higher than $300. Okay, and on that moment FLIR started to improve technology to find something that can be smaller, and then we are coming to the FLIR core. At this moment it's not only a concept, it's a product which is already existing on the market. And based on this core we have already first products. Only in this small tiny core we have 100 patents, so you can see how quick it's going with thermal. Only the small core is 100 patent core, that's like eraser on your pencil. It's first thermal imaging camera which you can really directly slide onto your iPhone. I will show you a short movie. It's a piece of good production. Maybe a little bit funny, but it will give you impression how thermal technology can be used. So enjoy the movie.
So it's a bit of a fixer-upper, but you're not going to be able to beat the price, especially after what happened
Look
here.
at all of this potential.
It's a dream. I love it.
Would you look at that closet space?
It's amazing.
Black cat. There's something I should tell you two about this house.
No, say no more.
It's perfect.
Honey, this house is kid-friendly. Come on.
Do you feel a draft?
It's horrifying. Look how much heat is getting lost through the window frames. This place would cost a fortune in energy bills. Come on, honey. We're getting out of here.
Really? The energy?
Introducing FLIR One. The world's first personal thermal imager slides right onto your iPhone 5 to help you locate horrors around your home before they haunt you. FLIR One. See the heat.
So as you can see, based on this core, we have already existing product on the market with a nice thermal picture, but you don't have to be afraid that we have only product for Apple users. We have also something for normal users, so Android users. So, second generation.
It's pretty rare to change the way you see the world. To take it, shake it, and turn it upside down. For some, it may only come once in a lifetime. But for others, a new perspective opens more doors, more opportunities, and new ways of thinking. We started by showing you the world in a whole new way when we put advanced thermal technology in the palm of your hand. But that was just the beginning. Because now, we're changing the game, again. Introducing the next generation FLIR One. With a new Lepton infrared camera and advanced MSX technology, the new FLIR One uses 2 cameras for unmatched detail and image clarity. And best of all, it's now available for Android phones, iPhone 6, and iPad, so everyone can see the heat. We've changed the game once, and now we're doing it again. FLIR One, see the heat.
Okay, so also we have second generation of FLIR One, this thermal camera. So based on thermal core, we have already ready products. But of course, we are not here to talk about ready products. For sure, we have to go a little bit to Lepton core. But we have one product more. It's C2 camera. It's first pocket small portable camera, which is also radiometric camera. So you can select on the touch screen when you're looking on your scene. You can select point, you can pinpoint this point with your finger, and on the screen directly you will see information about temperature. So the C2 camera is also providing radiometric information from the picture. Also you can snap the picture, and later during post-processing on your PC you can measure temperature in every pixel of that picture. So we are providing not only visual information, but together with this visual information we are also saving radiometric information for every single pixel in that picture. We have also AX8 camera, which is produced for automation control. The camera can be also installed in, for example, in the server room, also to check if all is going well, if you don't have problems with heat in some points on your server, on your power supplies. But also it's really a camera to control automation process. We have also, based on this new core, Lepton core camera, which is for the security market. It's FLIR Bullet camera, PCX series. It's camera which can detect person, the small mini bullet. This camera can detect person, so human size target from the distance of 60 meters. Of course, it's not the same range like with pulled cameras, because for example with pulled camera we can detect person on 25 kms, and this kind of cameras is used, for example, by the border control, also in Poland. But for some commercial security applications, 60 meters is always, not always, but often enough when you have a small warehouse. If you would like to have security behind your house or in the garden, very often 60 meters is more than enough. And then we have also camera which is also radiometric, a little bit like C2 camera, but looked a little bit more similar like cameras which were available before. It's, let's say, typical design of thermal camera for radiography, for checking buildings, or for engineers to check electrical installation. This picture from Lepton core, as maybe you saw already on the movie about FLIR One, this picture is really extra detailed. FLIR Lepton core is only 80 by 60 pixels, but what we are using in all these products, we are using MSX technology. So in every product like FLIR One, in C2 camera, also in that camera, we have always two lenses. We have one lens which is not with behind that lens we have normal visual camera, and also we have Lepton core. And we are mixing these two pictures together. So from visual camera we are taking details, and these details we are putting behind thermal picture. And I will show you a little bit how this technology is working, also based on short movie.
Introducing MSX, Multispectral Dynamic Imaging, the new onboard fusion technology that provides extraordinary thermal image detail, exclusively from FLIR. Available on the new T440 and T640, MSX enhances infrared video and stills with visible spectrum definition in real time right in the camera to clearly highlight where the problem is, so you can easily show customers and coworkers what needs repairing. And MSX images are fully radiometric, so you can adjust them and add measurement tools just like any other FLIR JPEG. Quality so good, you won't need a separate digital photo for reports. On board, real time, right now. MSX Thermal Image Enhancement, only from FLIR.
Okay, so thanks to that MSX technology, we are mixing two pictures, and then we have really extra detailed picture. So you know already which kind of products we already have in the market, what is already ready, but now it's time for universities to also improve this technology to maybe find out something really new. So we have to come back really to this core. We have three different kinds of cores. We have two non-shutter cores without shutter, which is in front the core, with two different angle of views. And last core, the silver one, we have it's shutter core, so in front of a microbolimeter, which is inside. We have small shutter, which is, let's say, cleaning thermal noise from the core, from the sensor. This is how this small core looked inside. This price of the core can be so low thanks to that the lens inside the core is as small as possible. One of the most expensive thing inside thermal cameras always optics. This optics is always produced, mainly produced from the germanium. It's we cannot use glass because glass is completely broken infrared, so we have to use germanium. Also, sometimes we can use silicon in some products, but mainly we are using germanium. And germanium here, or silicon in this camera, can be really small, and thanks to that we can go down with price of that camera. Here you can see a little bit more technical details about Lepton core. We have $2 on the right side, so you can see that it's really small sensor. Dimension, it's here for us. What's interesting, it's field of view, 51 degrees horizontal field of view, for example, for this sensor. And as I said already before, we are using long wave infrared wavelength from 8 up to 14 micrometers. So typical wavelength for uncooled cameras. Resolution is, of course, not very high. It's only 80 by 60. So when I will come with this resolution, normal visible camera, people tell, oh, maybe you're stupid. And now we have already 10 mega camera, megapixel. We are giving this one only 80 by 60 pixels, but for radiometric, for security, for short distance and movement is more for sure than enough. As you saw, we have already products based on this resolution. Thermal sensitivity, we have less than 50 millikelvin. It's 0.505 Celsius temperature difference, so this is something that we can show in the picture. We've integrated inside this core thermal image processing. This I will show this video pipeline. I will show you a little bit later. We have optional temperature stable output, so we can also have this radiometric functionality in Lepton core. And frame rate from this camera is 9 Hz, so 9 frames per second from this camera. We have 32 pins. We have full documentation for this Lepton core. So it's not closed products, but it's really product for like we mentioned before. For example, for startups, for own project, own ideas. So 32 pins which you can simply connect to your device. For example, to Raspberry Pi, you can prepare your own socket. You can prepare your own board for this FLIR Lepton core. And here on the top you can see, let's say, naked core without a socket, and on the right side we have this thermal core. Inside this 32-pin socket. It's standard Molex socket, so you can take every socket from the market. It's not some special socket. So 32-pin Molex socket is good also for this Lepton core. Here we have also spectral response from Lepton core, so you can see the best response we are getting from 8 microns to 14 microns. So this wavelength which we are using are to create a picture from infrared radiation. Here we have some dimensions of Lepton core. It's really small, so I can show you a camera which is produced based on this small core, so also you can see how small is the lens. You can also take a look what is the quality of picture. This is a little bit like a gadget. It's not a product which is re-existing on the market. This you can use to check if bread is fresh in bakery. You are going morning for the shops, so you can take a look. So as you can see, it's a really small product. In front you can see Red Bull logo and Infinity Red Bull team, because FLIR is also sponsor of Formula One first team from Red Bull, also from Infinity. So it's really a little bit like a gadget. So you can find the heat. And this is how camera module looks inside, because FLIR Lepton core is not only the picture sensor, it's also digital signal processor inside. We have different ways to supply power to the cameras, different power inputs to the camera. We have ready commands which we can send to shut down the camera, to reset, and we have then camera clock generator. We have control interface, so serial control interface. We have optional video interface, and also I2C optional multiplex interface also to program camera. This is what is important in the thermal core. We are not getting only ready video output from FLIR Lepton core. We can also work on a raw picture inside DSP, so we can also change configuration inside the core. We are not playing only with ready picture, which we are getting from this Lepton core. Here is the video pipeline inside digital signal processor, which we have behind sensor. First thing is non-uniformity correction. So we are trying to uniform output from the camera. Always we can have like a drift effect inside thermal sensor. So when you are starting to work with temperature which is around -10 degrees, and then you are going up to 50 degrees, then you can get really like a drift effect, so it's like additional noise. And this noise we are trying to uniform with this first block in our video pipeline. Then we have defect replacement. For sure we will not launch on the market sensor where you can find more than one defected pixel. But when we have this one defected pixels, we can select neighbors, we can count optimal value of this defected pixel, and then we can replace this in ready picture from the core. Then we have temporal filtering to reduce temporal noise, so it's next part of this video pipeline, and then after these 3 blocks you can already get a picture without AGC, so without automatic gain control. But we can also go through this block of AGC. AGC, it's like I told already before, it's automatic gain control, so we are trying to improve contrast. And here we are coming with 14-bit pictures, and here at the output we are getting already with better contrast pictures 8-bit picture. And again, we can take a picture after AGC, so without colorize, but also we can colorize our pictures, so we can get colors. This picture will be not anymore black and white, so a little bit like you can see in our small gadget thermal camera. We have also colors, and after this block we are getting picture 24 bits, so we are also getting a little bit more information about colors. Here's our Lepton core already inside the socket. The socket is already prepared to connect this Lepton core to Raspberry Pi, so you can program your own software inside Raspberry Pi, and simply you can, on this socket already, which is prepared, you can connect Lepton core to Raspberry Pi. Here is different already picture with the socket connected already on board. Here's also an example where already FLIR Lepton core is connected to Raspberry Pi, and here is different example where Raspberry Pi is already packed in small housing, but here also is thermal camera, but also normal visual camera. So also you can try in your own application, you can try to mix this picture a little bit like MSX technology, but the MSX technology is patented, so you cannot get, let's say, this algorithm of mixing pictures straight from FLIR. This is something what you have to find out by yourself. So only from FLIR you can get thermal pictures. This mixing of pictures, it's let's say impossible to get. It's not for developers. We also have full documentation, but also you can Google or look in GitHub. So we have a lot of already existing libraries, existing implementations where which you can download, you can upload on your Raspberry Pi, and directly you will have pictures. Only you can start to build only application around this already existing parts of code. We have also implementation to connect Lepton Core to MATLAB, for example. So Lepton Core or thermal camera from FLIR also can be used in different environments or in third-party softwares. So this is a little bit the message which we would like to send to you as a university, as the environment. This product is on the market. This is something what you can use. You can use this core. It's only $150, so it's not something was really expensive. So to start today your let's say journey with thermal technology, it's really possible. Never like it was before. And maybe also a short movie about that, about what's possible.
There's no denying that the addition of the camera revolutionized the mobile phone as we know it. And from this revolution came countless apps that took it even further, letting us do everything from depositing checks with a click to translating text from a single photo. But after 15 years since the introduction of the first camera phone, isn't it time for something new? For something groundbreaking? For something that doesn't just capture how we see the world, but changes it? We think so. The new FLIR One thermal imaging camera opens doors to a whole new world of app creation. With our industry-leading technology and development tools and your innovative ideas, we can create devices and apps that were never before possible. Join the FLIR developer universe at flir.com/FLIR1/developer and show the world how the possibilities of thermal imaging can change the world as we know it. Let's reclaim revolution and be the first to show the world what's next. FLIR One, see the heat.
Also in the internet you can find already some existing, let's say, startups, some products which already are made by students, made by, let's say, home users, hobby users. We have, for example, a screen to make a thermal selfie. So it's simple. A screen with thermal camera on the top, a little bit like a thermal mirror, so you can check your fever before you're going out from home. Also, you can find already apps, so you can use Lepton Core and Raspberry Pi, and you can connect wireless through your smartphone. You can check what's going on, so you can also a little bit use this camera like a security camera. We have also on the market already special socket for the drones, so the small thermal camera can be inside the drone, and here's the picture took with 80 by 60 pixels. So a little bit you can see what is the picture from Lepton Core when it's flying in the drone. And here we have also one of the example. It's thermal core mounted, so it's a little bit over the hand, and you can control your keyboard with gestures. So. This Lepton Core can be also used for to control user interface. And also let me show you an example of that keyboard. So here we have a hand, and on the left side you can see that this guy on the right side is typing FLIR name with expression marks, so 5 different characters already typed. I think that this is only the beginning of all ideas which we can have from this technology. What for FLIR is important, what we already said today, it's important to take this idea from the market. As you can see, this timeline of technology evolution, it's shrinking now. It's this gap between new product and next generation is really getting it again and again smaller. So we cannot wait too long. So at this moment, this is a moment when you can, let's say, jump to the boat, which is a thermal boat, or you can again wait on the ground. But it's for sure a good moment to start with this technology. Because of that, we have also bring the HEAT event. So in December 12th and up to 14th December, we have Lepton Maker meeting. So we are collecting people from around the world, and they have 3 days to write down an own application based on Lepton core. They can present its own idea, and also they can get a cash from FLIR. So it can be fun. So it's hacker party. So you are all invited to this hacker party in the future. If you would like to attend, we are always open, and you are of course welcome. That's all about the future, about present situation of thermal. Of course, if you have any questions, I'm open to answer, if I will be able, of course. I hope this presentation gives you a little bit idea of what's possible now with thermal cores and what's existing and what we can do together. So if you have any questions, I'm welcome. If not, then thank you very much for it.
First of all, we should